Lesson 9-2, dividing by monomials. Okay. Well, the title should be dividing monomials, not dividing by monomials, or the same thing, because in some examples we'll be dividing by monomials. So in this lesson, you'll learn to simplify expressions involving quotients of monomials and to simplify expressions containing negative exponents. Why is it important? Because you can use monomials to solve problems involving finance and geometry. Okay, and let's take a look at this geometry example. The volume of a cube in which each side s units long is s cubed, okay, cubic units. So the ratio of the measure of the volume of a cube to the measure of the length of each side is s cubed over s. Okay, so since the formula for volume of the cube is s cubed and each side measures s, okay, the ratio of the measure of the volume to the measure of the length is s cubed over s. So how can you express this ratio in simplest form? Okay, just as we use a pattern to discover the product of powers property, we can use a pattern as well to discover a property for the quotient of powers such as s cubed over s. So in the following quotients, okay, each number can be expressed as a power of 2. Study the pattern of the exponents, and let's consider the number 64 over 32 is the same as 2. Okay, and if you notice, 64 is 2 to the 6th power, 32 is 2 to the 5th power, if you recall in the last lesson. Okay, and 2 is simply 2 to the 1st power. Look at the pattern. You're simply subtracting 5 from 6, so 6 minus 5 equals 1. And let's take a look at another number. 32 over 8 equals 4. And 32 is the same as 2 to the 5th power, 8 is 2 to the 3rd power, and 4 is simply 2 to the 2nd power. So we're simply subtracting 3 from 5 to get 2. Okay, let's look at the next number. 64 over 8 equals 8. Okay, and we know that 64 is 2 to the 6th power, 8 is 2 to the 3rd power. Okay, and 8 is simply 2 to the 3rd power. And if you notice, we simply subtracted 3 from 6. Okay, to give us 3. And let's take a look at the last example, which is 32 over 2 is 16. 32 is 2 to the 5th power, 2 is 2 to the 1st power, 16 is 2 to the 4th power. Again, this is simply 5 minus 1 equals 4. So these examples suggest that you can divide powers with the same base by subtracting exponents, which gives us the quotient of powers property for all integers m and n and any non-zero number a. Remember, a should be non-zero. Why is that? Because you cannot divide anything by 0. Okay. So a to the m over a to the n is equal to a to the m minus n. Okay. So to write s cubed over s in simplest form, we simply subtract the exponents. We know that the exponent of s is 1. So this becomes now s to the 3 minus 1. Okay. And it ends up with s squared. So in simplest form, s cubed over s is equal to s squared. And let's apply this in example number 1. Y to the 4th, z to the z cubed, all over y squared, z squared. Okay, first and foremost, we'll copy the problem. And then we break it down using the associative property. We now have y to the 4th over y squared times z cubed over z squared. Okay, group the powers to the same base. Okay, y to the 4th and y squared and z cubed and with z squared. And we simply follow the quotient of powers property where we subtract the exponents. So this becomes now y to the 4 minus 2 and z to the 3 minus 2. And you end up with y squared times z to the 1st, or simply z. Okay, let's take a look at the next one. In the next one, let's study the following methods to simplify b to the 4th. Okay, all over b to the 4th, where b is not equal to 0. Okay, the next one, 0 exponent. Okay, so in order to solve b to the fourth over to b to the fourth, let's take a look at two methods. The first method is definition of powers or expanded form. So b to the fourth is the same as, okay, let me write that out. Let me write a line first. Line. Okay, this works. So let's write like right here, so it'll be straight. There you go. Oopsie. There you go. Okay, and let's take another line here so I don't have to redo it twice. There you go. Okay, so b to the fourth is the same as b times b times b times b all over b times b times b times b. And if we start canceling out the b, this b cancels out, that's a 1, that's a 1, this b cancels out, that's a 1, oopsie, why am I pressing that button? Redo that, that's a 1, that's a 1, 1, 1, 1, 1, 1, 1. So they all cancel out, the answer would be equal to 1. Okay? And using method 2, which is the quotient of powers. In the quotient of powers, what do? We simply subtract, okay? We simply subtract, let's get rid of this one. We simply subtract the exponents, which is b to the 4 minus 4. b to the 4 minus 4 is the same as b to the 0 power. Now what do you notice? 1 is equal to b to the 0 power. Okay? So since b to the fourth over b to the fourth cannot have two different values, we can conclude that b to the 0 is equal to 1. This example and the exploration suggest, well, the exploration we did not do, so don't mind that, the following definition. But before we do that, let's answer this question in blue. How does the value of b to the 0 compare with the value displayed in your calculator for 2 to the 0? If you take out your calculator and type in 2 to the 0 power, okay, it'll also be equal to 1. Okay, so if you try 10 to the 0 power, take out your calculator, it'll be equal to 1 as well. Which brings us to the zero exponent property, which simply states that for any non-zero number, a raised to 0 power is equal to 1. Simply put, anything raised to the 0 power, and I mean anything raised to 0 power, will always be equal to 1. Okay? And let's take a look at a pattern that we can use for our next property. So we want to simplify r to the 7th over r third over r to the 7th in two ways. Again, we use the definition of powers or expanded form method. Okay, so we write a line over there. Okay, and let's expand this. Okay, r to the third is the same as r times r times r. R to the 7th is r times r times r times r times r times r times r. One more r. There you go. Okay, and we simply cancel out the common factors, common r's. That's 1. Cancel that r. 1 1. This r cancels out as well. 1 1. So if you notice, so what we have left is that 1 times 1 times 1 is 1, and this is r to the 4th power, because r times r times r is r to the 4th, so this is equal to 1 over r to the 4th power. Okay, and if we use method 2, quotient of powers, we follow the quotient of powers property, which simply states that we subtract 7 from 3, and we know that 3 minus 7 will be equal to r to the negative 4. Okay, and since we know that r cube over r7 cannot have two values, okay, we conclude that 1 over r to the fourth is equal to r to the negative 4. Okay, so what do you notice also? Let's take a look at the one in blue. Okay, well, it's not here, so never. Okay, here we go. Did the display on your calculator for 2 to the negative fourth equal 1 over 2 to the fourth power? Okay, the answer, of course, would be yes. Okay, so what can we conclude? We can conclude the negative exponents property, which states that for any non-zero number a and any integer n, a to the negative n is equal to 1 over a to the nth power. Okay, so let's apply this particular rule in example 2a and example 2b. Okay, so negative 9m cubed n to the fifth, okay, all over 27n to the negative 2 n to the fifth y to the negative 4. Okay, so first and foremost, let's copy the problem down. And after copying the problem, we simply break down the fraction. We break down our algebraic fraction. Okay, so we break it down by putting negative 9 over 27. Okay, and we group the like bases together. Okay, so we have m cubed all over m to the negative 2, n to the fifth over n to the fifth. Okay, and 1 over y to the negative 4 because y does not have a common base. Okay, so with that we follow. Okay, we simplify negative 9 over 27, which brings us negative 1/3. We follow the quotient of powers and we subtract m cubed minus n to the negative 2 is m to the 3 minus negative 2, and this becomes n to the 5 minus 5, as this simply becomes y to the fourth. Remember, because y over 1 over y to the negative 4 is the same as y to the fourth, following this rule right there. Okay? Oopsie, too much. All right? Get that rid of. Okay, there you go. Let's simplify further. Okay? And this becomes now negative 1/3. And then 3 minus negative 2 is 5. This becomes n to the 0 power and y to the fourth. And we know that n to the 0 is 1, so this becomes negative 1/3. Okay, times n to the fifth, y to the fourth. Now, why did 1 disappear? Because if you multiply 1 times n to the fifth, y to the fourth, this is all you're going to get, all over 3. Okay, and that is the simplest form. Why is that the simplest form? Because we don't have a common base anymore, and all fractions are in simplest form. Okay, and we don't have any negative exponents. So let's take a look at letter B and let's see how we can simplify this expression. Again, first things first, we copy the problem and then we break down the fraction, break it up. Okay, where you have now 5 over 2, 2 to the second, p to the sixth. Before we break it up, I'm sorry, we need to use the power of a monomial property where you need to distribute negative 2. Okay, distribute negative 2 to 5 and distribute negative 2 to negative 2, distribute 2 to 2, and distribute 2 to 3. So if you notice, 5, this becomes 5 to the negative 2, and negative 2 times negative 2 will give you a positive 4. 2 to the second power, and 2 times 3 will give you 6. Again, power of a monomial property. Okay, and then this is where we break it apart. Okay, where you have 1 over 2 squared. Okay, and we know that 5 to the negative 2 is the same as 1 over 5 squared. Okay, and we have a common base of p, so this is p to the fourth over p to the sixth power. Okay, so from there this becomes 1/4 times 1 over 25, and we follow the quotient of powers property where we subtract the exponents. 4 minus 6, it's always subtracting the the exponent of the denominator from the exponent of the numerator, so it's p to the 4 minus 6, you end up with 1 over 100. 4 times 25 is 100, p to the negative 2, and we know that p to the negative 2 is the same as 1 all over p squared, which is 100 p, or sorry, 1 over 100 p squared. So if you want to know another step before we got to the last step, this is actually 1 over 100 multiplied by 1 over p squared, because p to the negative 2, remember p to the negative 2 is the same as 1 over p squared. Okay, and that ends up with you end up with 1 over 100 p squared. Okay, the secret word for this lesson would be longhorns. Secret word would be longhorns. And that's the end of our lesson. Thank you for watching.